Here is the explanation of an experiment I've done to measure the specific latent heat of vaporization of water. First of all, you need to know what is meant by specific latent heat. Specific latent heat is the heat energy required to change the state of 1 kilograms of a substance from liquid form to the gas form or from solid to liquid. If the state was changing from liquid to the gas, this is called latent heat of vaporization. And if it was solid to liquid, that's the latent heat of fusion. The apparatus I used to calculate the latent heat of vaporization of water was an electric balance, an electric kettle, a stop clock, some water, and a thermometer. What I've done, I supposed to measure 1 kilograms of water, but it takes me ages to evaporate 1 kilograms of boiling water. Instead of 1 kilogram, I used only 0.2 kilograms of water, and I'm going to times all my final answers by 5 at the end. So I measured 0.2 kilograms of water and added to my kettle. Then before I switch the kettle on, I have to note the power of the kettle. The power of my kettle was, the maximum power of the kettle was 3000 watts. Then I switched the kettle on and allowed the water to boil. As soon as I saw the temperature of water reach to 100 degrees, then I start my stop clock and I let the time go until all the water evaporates. So when all boiling water evaporated and changed into steam, I stopped the stop clock. The total time was 2 minutes and 34 seconds. And if I want to change this into seconds, that's going to be 154 seconds. That's the total time takes to evaporate 0.2 kilograms of boiling water. So to calculate the energy, I'm going to use the formula E equals to PT. So the power of the kettle I used was 3000. I'm going to times it by 154 seconds. And that gives me 462,000 joules. That's the energy needed to evaporate 0.2 kilograms of water into to evaporate 0.2 kilograms of boiling water. Now, I need to multiply this by 5 to obtain the energy required to evaporate 1 kilograms of boiling water. So that's going to be 462,000 times 5, and that gives me 23.1 times 10 to 5 joules. Okay. This value is the specific latent heat of vaporization of water because that's the heat energy required to evaporate 1 kilograms of water, boiling water. When I compare my result from the experiments with the specific latent heat of vaporization of water in the data sheet, here we've got 22.6 times 10 to 5 joules per kilograms, where I've got 23.1 times 10 to 5 joules per kilograms. The reason I've got the slightly bigger answer was because some of the heat energy was lost to surroundings because the lid of the kettle was left open to measure the temperature. That's why we required more heat energy to evaporate the boiling water.